Welcome to XNA Tutorial 7, the first exclusive tutorial for XNA. So we're going to have better quality slides, we're going to have better quality discussions, and we're going to talk a little bit more stuff than on the preview ones. So expect better quality stuff in these exclusive videos. So what we're going to cover now are sprite properties, what every sprite should have, and we're going to cover just a limited number of them because we're not going to do much with the more advanced properties. Then we're going to discuss how to allow a sprite to move without using keyboard input. And finally, we're going to do collision detection for the sides of the game window, so your sprite doesn't float off into space and you don't see it. So let's discuss sprite properties. Sprites need properties to move or respond to user input. We'll use vector2 variables for most of the properties. The three main properties that we need to focus on are position, velocity, and acceleration. We need the position because we need to know where we are inside the game window on this current loop so we can draw it properly. We need the velocity to find out how to update our position for this loop. And then we need the acceleration. So we need to figure out how to increase the velocity to increase the position. It's like you're driving a car. You slam the gas. You don't go the top speed like that. It needs to be slowly going up until eventually you reach top speed. That's what the acceleration and velocity will go. Right away, you might have a 30 miles per hour velocity, and then it'll slowly go down as you reach top speed. It doesn't go on forever. You'll slowly go down to maybe even 1 mile per hour increase for this amount of time. The acceleration will increase velocity, and the velocity will increase position. Let's look at a game window. I'm using 720p because that's the easiest and that's what I'm designing most of my games on. So 720p is 1280 pixels wide and 720 pixels down. And this is what the game window will look like. Whatever is blue, we can draw our stuff in. How position works. The position variable will store the pixel location of the sprite. So referring to a 720p game window, position 0, 0 will be the top left. Position 1280, 0 will be the top right. Position 0, 720 will be the bottom left. And position 1280, 720 is the bottom right. So it goes 0, 0, we increase X as pixels, and we increase Y as pixels, until we reach 1280 by 720. If we go greater than 1280, it goes outside the game window over here. If we go greater than 720, it goes outside here. If we go less than 0 pixels high, it'll go outside here. If we go less than 0 pixels wide, it'll go outside here. So in my Phoenix game, I have a lot of sprites outside here because they're going to fly in from the left to the game window, and then it'll do a loop movement like this. And that will be determined by our collision detection with the boundaries. So what I teach you now, I use in my own game. So there's a little quick sprite I drew up. It's not that great. It's just this little smiley face, just to demonstrate movement. So assume we have a sprite attribute or property. It's a vector2 called position. Now when our position.x increases, our sprite moves to the right. When our position.x decreases, we move to the left. When our position.y increases, we move down. When our position y decreases, we move up. If we have the combination of those, we move right up, right down, or left up, or left down. If we press the left and right key at the same time, we don't move at all. Up and down at the same time, we don't move at all. All four, we don't move. Increase in position. We need to increase position because the sprite will move either by keyboard input or not. With this tutorial, I'm going to discuss not. So it moves with velocity or with velocity and acceleration. I'm only going to cover with velocity because we do not even cover acceleration in this tutorial. So just focus on the with velocity. We have a position and velocity variable of type vector2. Now this is what the math looks like to increase the position. The position plus equals velocity semicolon. Now this may look a little bit confusing, but this is equivalent to the following line. Position is equal to position plus velocity. This is equivalent to this. That needs a semicolon at the end. But those two are equivalent. The vector2 class allows addition in this way. Okay, now here's the coding to get our sprite onto the screen and do the movement of it. So I already created a project. To do that, go to File, New Project, and choose Windows Game, and name it whatever you want. I named it XNA Tutorial 6, which should be 7, but that's a mistake. Okay. So we have nothing in this game, just like we did on Tutorial 5, or Tutorial 6.